Thanks for stopping by Bissell Maple Farms YouTube channel. I am Nate. We're in Jackman, Maine. And there's a lot of maple syrup made up here. And these are all off-grid sugaring operations. I'm pretty sure the sugar house I'm standing in makes more maple syrup than the state of Ohio, where I'm from. And you got one dude doing it all. So we're here to look at some kettles that are automated. So one guy can boil for 70,000 taps. He's a good guy. I mean, he's moving. But he's just filling totes after tote after tote while his kettles make all of the maple syrup. So the whole system's automated, and I think you'll find it interesting. Anyways, thanks for stopping by. Catch you at the end. So has he been boiling all morning?
Fresh go about 7 o'clock this morning.
And he's not even here, Clayton.
Nope. Kettle 1, 2, 3 are going. Kettle 4 is filling right now.
I got you.
So we're at 213. We got a little bit of ways to go.
Going up a tenth about every 3 seconds.
There you go. We're in the boiling mode right here. Kettle 4 is boiling and filling all at the same time. So we can go back here and we can look at, this is about 199 gallons in there roughly. Gotcha. That might have been a short fill. Usually it's 250 a finished syrup.
This is pretty cool.
We're setting it for 218. This concept was started because there's a lack of labor available in every industry, especially the maple syrup industry. So that being said, standing in front of an evaporator can be time consuming and it can also be labor intensive, right? So what we've done is we've taken the labor out of this. The design with this was to fill a kettle and boil it down to syrup and do that in a 3.5 hour period. So it's a 3.5 hour turn. We figured 4 hours, to be conservative, gives you a little bit of wiggle room. But the design intent is 3.5 hours. The 30,000 foot view is the kettle fills with liquid. It boils down automatically. When it gets to a set point on temperature or bricks, it dumps. When it dumps, then it goes to a bulk tank. Once it's empty, then it gets sprayed down, gets rinsed, then it gets refilled with sap again.
That's all automated?
It's all automated, so it's a continuous process. That's the large picture scale. We have a lot of safeties on this for filling, so there's no cross-contamination. Also for draining, so that nothing goes to the drain. This project was an R&D project where all 4 kettles were tied together. For production purposes, we're going to end up with individual kettles that will talk to each other, but not be connected to each other. They'll have individual parts to them, such as pumps and filling components. They'll be easy to connect.
So what's the brains? Where's the brains of this thing?
Shows 4 kettles. So we can go kettle 1, 2, 3, and 4. Right now we have 3 kettles on. 4 is waiting for start. So we can set this up in a sequence so that it fills kettle 1 first, then it goes to kettle 2, kettle 3, and kettle 4. This tells us the temperature for each kettle, and it tells us that this kettle is on. We click on each kettle, we can have a main overview screen. So part of the main overview screen is we can have our set point, we can have our actual temperature, we can have this in auto or in manual mode. We can do a certain amount of cycles, so if we wanted to run each kettle in say 3 or 4 cycles and then be pulled off for a CIP function, we can. This also shows where we are in probe stages, so it shows the level of the tank. Also shows how many gallons are in there. So this guy right here is boiling. It's 215 degrees Fahrenheit. It's set for 218. We have 197 gallons in there, which equates to 14 inches. When this gets to set point, this will automatically open, drain, and refill. Right here we can see we're in the boiling sequence. We can waiting for the drain to close, filling, boiling, draining syrup, rinsing, and then starting again. We can
How easy is it to change like temperature set point? Does it do it automatically?
Oh, it's easy. Just plug it.
Okay, so he's got a 218, so it's like low pressure, or
That's a magic number for today.
I got
We're
you.
at a high elevation place. We can also set this for bricks. So you can actually see number 3, the build out slowly.
How do you know if it's closed all the way?
Because it has a limit switch in there. And the limit switch will actually tell it so it's calibrated.
So this doesn't matter as much.
Not at all. That's set because on a butterfly valve you can't close it all the way because of the torque setting. So this is set for torque setting.
I got you. This is looks complex.
It is complex, for sure. This is an R&D state, so just know that this is not production state. This is basically R&D state. So we're showing you some real life R&D.
What are the benefits beyond labor for a system like this?
It's absolute time management. You can't burn your syrup, and consistency. Also, this does incredible flavor profile. It's caramelization at its peak.
How do you guys get so much flavor and caramelization with a system like this?
So caramelization is a function of time and temperature. We give it the time and the temperature, and that's why you get the caramelization. While for traditional evaporator, you don't get the time and the temperature, right? You might get the temperature, you don't get the time. When you would RO to a lower bricks, you would get the time and the temperature because it's sat in the evaporator longer. Right now, with a traditional steam evaporator or a traditional wood-fired or oil-fired evaporator, you don't get the time and temperature. We get a light transmittancy of 4 less than you would with a traditional evaporator, and that's our testing. So you're sacrificing 4 light transmittancy for exceptional flavor.
Gotcha. The BTU of the boilers, you're running, can all 4 fire with the boiler you have?
Yes, so this is set up with a 200 horsepower boiler. Each kettle's about 40 to 50 horsepower.
Gotcha.
Kettle. So if you had 2 kettles, instead of having a 200 horsepower boiler to get your job done, you would only need a 100 horsepower boiler.
For 2 kettles?
For 2 kettles. You have to think about production per 24-hour period, not production per hour. So with a traditional evaporator, you're working in your equation of production per hour. With this, it's production in a 24-hour period. The boiler's going to run longer. These are going to run while you're sleeping. You could be in the woods. You could be fixing equipment. You could be sleeping. You could be eating. You could be going to town. You could be going to the parts store. There's a infinite number of things you could be doing.
So how many taps are they boiling for here?
This is about 70,000.
70,000 taps. The RO's already made the concentrate. And you got one guy running the sugar house.
One guy. That's it.
So he's basically just running the filter press full go.
Yep. And this morning he said he had a number of chores to do. He was able to complete those chores while making 1,000 gallons of syrup.
All right. So you want to walk through like how the sap comes in from the beginning.
Right now we're stop filling, so we're actually doing a CIP function. This is a heat exchanger. We're actually capturing the condensate that comes out of the steam
I got you.
on the system, and it goes through the heat exchanger. So put your hand on this pipe. You can feel how hot this guy is.
So steam, condensate capture. So this is condensate.
Sure is.
And that's preheating sap?
That is.
I got you.
So you're coming into these kettles about 200 degrees.
Just right at the beginning.
Exactly.
You've already made the BTUs, use them.
Exactly. So from there it goes through the heat exchanger and it starts filling these tanks. We turn the steam on the kettle as we're filling it. So what that does is it allows it to start boiling sooner. We're using some Perry pumps here for injecting defoamer into the system. The defoamer does not need to run the whole time. The boil is actually so violent that it'll actually kill the foam. We're actually geared up to put air into the system as well, so we can use a blower and pump air into the system. And what that does is that can actually break the surface tension as well and help that boil.
How about the fill? So you're filling from the bottom.
We are, absolutely.
Okay.
Yep. There's a bottom cone, but this fills, 6-8 inches off of the bottom.
Where's the pump that's filling the sap? Filling the kettles?
We have a pump over here, and this guy is actually filling concentrate through.
I got you. So this is your pump that's feeding the concentrate through the heat exchanger that's being heated by the condensate.
Yep.
Gotcha.
We have automatic steam valves, so the steam actually comes on. Not only are the tanks Jackman, but they also have a steam coil on the inside. So we have a patent pending design on our steam coil. What that does is allow us to get the heat transfer more efficiently than a normal coil, and it also keeps the niter off of it. So it's kind of like a niter fighter, I guess.
I like it. That's cool.
Yep.
So what would be next? Do you have level sensors? So you're filling. How does it know to stop filling?
Yeah, so we actually have a level sensor in this tube right here, and it knows exactly to the fraction of the inch how much liquid is in there and how much surf we are making.
Do you have duplication on your level control, or is it just you trust it?
Oh, it's very accurate, dead on accurate.
I got you.
No question.
So that actual level sensor is not inside the kettle, but as you fill it, it actually fills from the bottom up into your tube.
And that was actually tricky, so we were able to drain that column every day. There's actually not a gasket in the top, so there's no vacuum there.
I got you.
Air actually goes in there, so that column's drained every time.
I got you.
From there, it surf drains out of the bottom. And when it does, it comes into a common pump. We pump that from here to a bulk tank for storage.
So this is finished syrup.
Exactly.
It's going into this bulk tank. It's finished syrup.
And in this situation, we're actually reading the finished syrup in there. So you can see this is going to get standardized to the bricks that's needed. It's not quite there yet. And then we can add water, or we can send it to the kettle again.
So this is finished syrup in this kettle. Is this heated or mostly insulated just to keep it hot?
It's just an insulation.
Gotcha.
Yep. So you can make multiple batches of this system. It can get pumped over, and then from there it can get stored so you can press all your syrup at once.
Gotcha. And this is just DE for filtering.
Yeah, that's just a mixing tank with an agitator, and you add DE. Once it's standardized, you add DE and it goes through the press.
I gotcha.
Yep.
So explain the process of once you fill it, it doesn't add any more as it's boiling, does it? Or does it just finish a batch?
Nope. So what it does is it fills to a certain level that we've indicated on the HMI and the PLC, and at that point, or the touchscreen, and at that point it boils down. So it's a batch process. We don't want to keep adding sap to it. What we figured out is when you add more sap to it, it keeps getting darker. So we've found a happy medium where we lose some light transparency, but we gain that flavor profile, and we're able to turn this in a quicker period.
With all the controls that you have, just explaining it to me, it sounds that you could actually, if you wanted to, keep adding sap and make it the color you want.
Absolutely, without question.
Like you could actually you could program it and say, make me dark robust at pretty close to this TC. With the incoming sap measuring, it could probably keep adding. I don't know what you call that, batching basically.
Yeah, so there is a simmer control that we baked into that program. What you could do with that is basically keep the surf at a certain temperature. It's not going to, quote unquote, get done. It's just going to sit there and basically caramelize, and it could fill in a continuous process in that sense. And then, yeah, you could set up some sort of digital light transmittancy, and you could make the color that you want. So the design intent behind this was for time management. The flavor profile and the color, those are all byproducts.
Gotcha.
That's something we discovered along the way.
You could actually control multiple variables differently.
Without question.
No kidding. So how many, when you batch a batch of syrup, what's the time based on the bricks? How much are you getting, I guess?
So if you put, say, 850 gallons of concentrate in, maybe at 24%, you're going to end up with 250 gallons of syrup in a total of a 3.5 hour period.
Gotcha.
So that's from when it fills to when it boils to when it drains, rinses, and starts again.
So 1,000 gallons in a 3.5 hour period, but it is all automated. You don't have to babysit it.
Exactly. So you could do that 6 times over. So this is capable of doing 6,000 gallons a day.
I got you.
Of syrup.
That sounds like a tanker to me.
Absolutely.
That's a tanker. So you could actually park a tanker out back and fill it up. That's awesome. We could automate tanker filling. Huh.
So
what else is valuable or do you think would be helpful? As you've explained, it looks really complex when you look at it.
it is.
But as you look at it and explain each piece, like how do you know if a valve goes down? Will it tell you?
Yeah, so there's feedback into the PLC on the valves. So there's a feedback loop. So for instance, if a drain valve is open and it's not supposed to, the program won't sequence to the next step until it sees that closure. And it's going to tell you on the screen that that valve is not closed.
I got you. So those are steam valves.
That is automated steam valve. That's an automated control valve. This project was designed for time management. Not everyone has enough labor, and everyone has something to do. So that being said, we designed this project so that you don't have to stand in front of an evaporator. This also gives a level of automation and consistency to the syrup that you make. We are automating the manufacturing process of maple syrup.
That's
We're
awesome.
using high pressure steam to make maple syrup instead of a conventional flame under a pan.
How is it you are automating this? Like, what is a traditional evaporator? What would it require?
A traditional evaporator generally requires an operator. So if someone's standing in front of a draw-off bin, there's automatic controls for an auto draw-off, which is a common term in the industry. It basically senses temperature and opens a valve to release the maple syrup as it's done. However, at that process, the guy making the maple syrup or the person making the maple syrup has to actually take action and take that syrup and move it from the draw container to a filter press, standardize it, and get it moving.
So in all reality, you're able to take that operator that's normally running the evaporator, maybe put them somewhere else, you're short-handed.
Exactly. We can move them down the line. So instead of being the guy that's making the maple syrup, he's now the guy that is taking and filtering the maple syrup and maybe standardizing it.
Just like they have in the background here.
And he doesn't necessarily need to be there as the syrup's being made. So the syrup can be made at an off time, maybe while you're sleeping, maybe while you're going to town for parts, maybe while you're fixing other equipment on the farm, maybe while you're triaging some problems in a pump house, or maybe while you're trucking sap.
So it's an autonomous maple syrup production system.
That's exactly it.
And then so, Sean is basically filtering syrup and making sure that the syrup's to the right density to the 10th of a brick.
Exactly.
And filtering, and then also he's moving material. Honestly, that's what he's doing. He's just moving finished product out of the way.
Exactly. Yep. This is a factory. Essentially, the sap comes in the back, it gets processed, it gets turned to maple syrup, and it goes to the front for storage or for removal from the property.
So it's by temperature you're controlling this.
Exactly, but this is set up not only by temperature, but we can control it by grits. We can put an inline refractometer in line, and we can set the exact concentration of maple syrup, sugar concentration to get.
In a way, this is like an evaporator / auto draw-off tank combined.
All combined, you're absolutely correct.
So instead of it being 2 steps, it's done all in one.
Exactly. So let me show you the touchscreen automation. This shows all of the kettles that we have. We're going to individualize the kettles. This is just for R&D purposes. We can see that these kettles are on. We can see that what their temperature is. We can also pull out our phone and we can look at the app, which shows this. You can control everything from an app. So if maybe you're not at this location, you can see what's going on. If we pull up kettle 1, we can see the set point right here. The temperature is actually really close to the set point that we have. We're setting for 18.5, we're to 18.2. We can turn everything here on and off manually. We can also see the sequence. We're in a boiling sequence right now. It's going to go to draining syrup here very, very shortly.
Gotcha. Where will we see the syrup coming out?
You won't actually see the syrup coming out. The drain valve opens and the syrup goes and the pump starts down here. So that is what pumps it to the bulk tank.
So that Gold's pump,
That's a gold pump, yes.
it'll pump hot syrup?
Yep.
Wow.
It's the correct pump. So it's not just a standard well pump off the shelf.
I did not know that.
It's a special pump.
I gotcha. So controls, I would just go through the controls. I mean, to us it's simple.
This is simple for us. This will actually show the level. This one has 158 gallons in it at 12 inches. So that might have been a smaller batch that Sean had run.
But this should actually be dropping as the temperature goes up.
Absolutely correct.
Gotcha.
Yep.
Man, you're like a chemical engineer.
And we can also track how many gallons this product makes. You know, there's some rough calculations in the geometry on it.
Sure.
But we're pretty accurate. So you would know, obviously you're going to weigh your syrup at the end and how many pounds that you make. But this will give you a rough idea of what you actually make.
So Sean could start this in the morning before he even gets in here.
Screening right now. So
This valve's going to open?
This valve down here just opened, or it's opening.
So, valve open. This pump will be turned on.
This pump is running right now. That's hot.
Woo. So there's maple syrup being pumped from this up and over
To the tank.
and then you guys basically, what do you call this? A normalizing tank.
Yeah, it's a bulk tank that's been repurposed for normalizing.
I got you.
Yep. And this allows us, maybe we'll make it a little bit heavy. Allows us to add a little bit of water to standardize.
Gotcha. Yeah, this is cool.
Remember, we were about 158. We're 120 now, so we've already spelled 30 gallons out of this tank, and it's dropping. And this sensor also tells us how many inches, right? So we're at 10 inches, we're dropping.
Gotcha.
This also shows you, like, for instance, kettle limits are not okay. So that's telling us that that drain valve is open, and we could not restart this even if we wanted to.
I gotcha. There's a lot of safeties built into this.
Yes.
You're not relying on a tired operator's memory.
Exactly. This would be pretty easy to send a couple 100 gallons of syrup to the drain. We do not want that. We have not had that, and we won't do it.
So the investment will probably pay for itself in mistakes avoided.
Exactly. It doesn't matter what kind of operator you are or owner, you've made the mistakes. Whether you admit to the mistakes or not is another thing, but you make those mistakes. This removes all of that from it. You
So
press
this
go
is-
and it does its job. And this guy shows up every day.
I was gonna say, this never calls in sick.
Never. This guy shows up every day.
Yep. Well, the gist is, this is an automated process. It's very quiet because it runs on steam. And these kettles here, well, there's one guy doing it all. And 70,000 taps, automatic maple syrup making machines. I mean, they are evaporators. They're just cylindrical instead of, rectangular. So I guess if you like square things, this probably isn't for you. But if you like autonomous maple producing machines, well, you might want to inquire about these. So I'll definitely put some information in the link down in the description. Reach out to NES. They pretty much innovate for the rest of the maple industry. And then what happens is once Clayton gets it out there, their competitors get in into a sugar house where something already exists. They basically copy what he does. So he is definitely the brightest mind on the equipment side. Everybody knows it. And yeah, he has an infinite amount. So I highly recommend, if you can, work with NES. I am not paid to do this. I do not take money from Clayton. What I have gained from meeting Clayton Christie and working with him is I have met people I will be friends with for life, farmers that I never would have gotten to meet, and that has infinite value. So I feel pretty fortunate to have been able to do this. But yeah, we talked about it and I said, no, you know what? This is working for both of us. So I do not make a dime from any sort of equipment deals. So, and I think it's important that it stays that way. because I just want to deliver things how I see it. So anyways, thanks for stopping by. Catch you in the next episode. Yeah, this is cold syrup from yesterday. It smells like a toasted marshmallow. There's a ton of flavor in that. There's a ton of maple flavor in this. Cheers. I can just drink that.
Mama always said I was born on the wild side. One foot in the flames and the other trying to walk the line. Can't say I never saw it coming, I can see the warning signs. Mama always said I was born on the wild side. I guess Mama was right. 'Cause when the clock strikes midnight, I'm gonna ride the lightning, feel the thunder, till the darkness pulls me under. Gonna fly on wings of fire, breathing good, Lord lifts me higher, singing oh when they call me home, singing oh when they call me home. Gonna ride the lightning. There's a man in a black coat standing at a crossroads, with a pen in his hand and a long list of lost souls. They say flips a coin, fools and a fool's gold. There's a man in a black coat standing at a crossroads. I hope he lets me pass by. When I close my eyes, I'm gonna ride the lightning, feel the thunder, till the darkness pulls me under. Gonna fly on wings of fire, breathing good, Lord lifts me higher, singing oh when they call me home, singing oh when they call me home. I'm gonna ride the lightning, ride the lightning, ride the lightning. I'm gonna ride the lightning, feel the thunder, till the darkness pulls me under. Gonna fly on wings of fire, breathing good, Lord lifts me higher, singing